Hello everyone. So in this video, we're going to be discussing how to model playoff games in like say the NBA playoffs. Right now, like the NBA finals are going on between the Bucks and the Suns. So we're down to the last two teams. But basically, I want to look at it as the way we're going to look at it is basically if a team like basically when a team loses or gets out of the playoffs, they've played a certain amount of games. And I want to like say, for example, let's start here. So like say the Blazers, they got out in say in 6 games this year. But for example, let's say they got out in 11. So they played a total of 11 games. I want to basically create something in Python that will list out basically all the combinations that could have happened in terms of the games that they played. So they got out. They played a total of 2 series, first and second round, and then for example, so in the first round they could have played 7 games, and then in the second round they played 4 games. So that's one option. Another option could be in the first round, they play 5 games. And then the second round, they play 6 games. So I want to develop I want to write something in Python that will give me all of the combinations of the games that they might have played. Although we know definitely like how everything played out, but say for example, this is the only information we have, and then we'd have to output that. Oh, one, like this is how their playoffs went. It's one of all of these combinations that actually happened. So yeah, let's get started. So basically in this one, we're going to be doing just with for loops. For loops in order to get all of the combinations that could happen, knowing that there's 4 series total that any team can play, and then each series being anywhere from 4 to 7 games. So let's get started. First, we have to find all of the options. So basically, we're going to create an empty array. And the good thing about Python is that as compared to Java, is that like you can create an array and each element of the array doesn't have to be the same size. So say you wanted to do an array of arrays. Each element can be different. So each array element could be like size of 1, 2, 3, and 4, which is good. So let's get started. So first, we're going to do our single series combinations. So we're going to do our for loop I in range 4 through 8. 4 through 8 meaning it's going to go through 4 through 7 because 8 is exclusive. So we're going to append. This is going to be, we're going to append the array of the single value. So that's our single series. Here is our 2 series combinations. So basically is just taking the first one and expanding it out. 4 through 8. So it's kind of like, this is like more into the recursive zone. So we're trying to recursively find all of the combinations. Another thing that's worth noting is that, so this we're going to add I and j. So 4 and 4, 4 and 5, 4 and 6, 4 and 7, and so on. So all of the combinations. Another thing to notice is that it might seem like, what are the total possibilities? Since it's not guaranteed that every team will play up to 4 series. You have to add all of them. So this single series is 1. You're going to get 4 out of this one. you're going to get 16 combinations out of this one. And then in 3 series, you're going to get a 4 raised to the third, which is 64 total options. And then in 4 series, you get 256 options. So then in total, all of the combinations will be their single, 2, 3, and 4 series. So let's just write it up here. And this is more of a brute force. It's trying to find all of the combinations that can possibly happen. And then later on, you know how many teams that, how many games that the team has played. And from there, you can just do an equality check that, hey, is this a combination that they might have played? So yeah, let's see here. So basically it's just adding another layer. So, and then I, J, and then K. Okay, these are all of our combinations. So we can see how many total combinations there are just by calling length. So print length of X. So then we can do that here and then just run or call our script. Call our script here. And it's 340, meaning, yeah, so those are all of the possibilities. So now what we can do is we can create a variable here called total games. Total games played equals, like, say 11. And then we're gonna go and just do a for loop through X in length of in, so it's going to be range and length of X. And then we're going to do this. So there's a keyword, sum. So if you do if sum of X equals, we can just say total games played. Then we're going to print out X. And that's basically all it's going to do. Actually, it's going to be X at I, right? X at I, right? Because it's the element, it's the array within the array. So yeah, that is, we're gonna try like a couple of these. We can try a little bit to change this out just to see if it makes sense. So let's clear this output and then we'll run it. So now we get all the combinations. They could have 1 and 4 lost in 7, 1 and 5 lost in 6, 1 and 6 lost in 5, 1 and 7 lost in 4. So those are all the combinations that could have happened. The other thing that is not included in here is the winning information, meaning that, you know, like definitely if they win the first series, then they can move on to the second series. But then knowing that you're limited to 11 means that definitely there's no way that you could have gotten to the third round, because getting to the third round, you need to play 12 games minimum. Yeah, so this is 11, and then we can try like 17. We'll save the script and then run it. So now we have more options. If a team played 17 games, these are all of the options that could have happened. And these could all be, if you look at these ones, these 4 options, it could be, they could lose in the finals, right? Or they could equivalently win in the finals as well. So these can be go both ways. So let's try 28. So we don't have that information. Let's go here. And then 28 is definitely, this is the max that any team can play, is 4 rounds of 7 games. And then we could try like, we could try 3. But 3 is not, I mean, if we try 3, we're not going to get anything out because the minimum amount of games a team can play is 4. So yeah, we could try another one. Like we can try like 22. That could be that could be interesting. So yeah, 22 has a lot of options. So how, and the cool thing about it is like, it's basically a tree. Like all of these are kind of like the leaves of a tree. And then that the team is going to ultimately play one of these combinations. It's going to land like that. So yeah, hope you found this video useful. Any comments, suggestions would be really helpful for me. Thank you. Keep working on whatever you're doing, Python, learning Python. Definitely, it's a very powerful language. Yeah, thank you, and see you in the next video. Bye.